All right, so in this video, we're going to be simplifying square roots, and we're going to be using two different methods. One method is going to be finding the greatest perfect square which you can divide by, and then the second method is going to be the factor tree method. It doesn't really matter which method that you decide to use, just pick one that works best for you. So in our first example, we have the square root of 125. And so I'm going to think to myself, what is the greatest possible perfect square which I can divide 125 by? And that number is going to end up being 25. So 25, and then the other number that I have to multiply 25 by to get to 125 is going to be 5. Okay? So now this is great because the square root of 25 is equal to 5. So I can just pull out a 5 then. This will turn into a 5. And then 5 is not a perfect square, so I'm just going to have to kind of leave that one as it is. So this will just end up being 5 root 5. And so that would be my answer for number 1. Now, again, I can also do this using the factor tree method. So I'm just going to rewrite the same thing on the side here. The square root of 125. 125, that breaks down to, again, 5 and 25. I'm just dividing 125 by 5 because I know that's divisible by that. And then 25 breaks down to 5 and 5 as well. And so if I do the factor tree method, I'm going to be looking for pairs here. And so I see I have a pair of 5s here. And so when I have a couple or a pair, I can go ahead and take that out of my square root. So then I'll draw my square root. 5 goes on the outside, and I still have this 5 left over. So I'll have 5 root 5. I get the same exact answer here. So again, whichever method you want to pick gives you the same exact answer. We'll do the same thing here with number 2. I have the square root of 108. So the greatest possible perfect square, which I can divide 108 by. You might have to think a little bit more for this one, but in this case, it's going to be 36. So I'll take the square root of 36, and then what times 36 gives me 108? That's going to be 3. So 36 times 3. Again, I'm going to simplify this. The square root of 36 is going to be 6. And then I'm still, again, left over with a 3 because the square root of 3, that's not a perfect square. So I'll get 6 root 3. Now, again, I'm going to do the factor tree method for this as well. So I will have the square root of 108. I'm just going to go ahead and divide this by 2 because I think that's the simplest way to go. So 108 divided by 2 will give me 54. 54 divided by 2, that's going to be 2 times 27. 27, I know that is going to be 3 times 9. And then 9 is equal to 3 times 3. So again, I'm going to be looking for pairs of the same number. So I have 2 and 2 here. I also have a 3 and a 3 here. So I can pull out a 2 and I can pull out a 3, but I will still have this 1 3 left over. So when I pull these out, I'll have 2, I'll have a 3, and again, I'll have that 1 3 left over. And that 2 and 3 that I pull out, I'm just going to multiply those two numbers together, which will give me 6 root 3. All right, moving on to our last two examples here. I have the square root of 54. Now, in this case, again, I'm going to go ahead and do one method for this one and then one method for the other one, just so we don't we just aren't repeating ourselves here in these questions. I'll do greatest perfect square for this one. So the greatest perfect square between 54 is going to be 9 and 6. So 9 times 6. The square root of 9 is going to be 3. So I'll pull that 3 out. And I cannot square 6, so it'd be 3 root 6. Now, one thing I do want to get into here is going to be imaginaries. So what if it instead was, let's not do an equal sign there. What if instead this was the square root of negative 54? Not much would change in what we're doing here. What we're going to do is we're going to pull out our negative 1. So it'll be negative 1 times 54. And then we can now proceed just like we just did. So 54, like we said, is equal to 9 times 6. And then I'll just do my same thing here. Now, when I pull out this negative 1, though, negative 1, the square root of that, is going to be equal to I. So this is going to turn into I. Again, the square root of 9 will turn into 3. And then my 6 will just be left over. Now, instead of writing I 3 root 6, we want to go ahead and put a real number first. So it'd be 3I root 6. So again, the same method we used for a real number will be kind of like the same exact method we're using for an imaginary number. The only difference is we are going to have an I between there, okay? And then our last example here, we have the square root of 128. This time I'll do factor tree. So 128 divided by 2 is going to give me 2 and 64. 64 divided by 2 is going to be 2 and 32. 32 divided by 2 is 2 and 16. 16 divided by 2 will give me 2 and 8. 8 will give me 2 and 4. And then lastly, I will get a 2 and a 2. So I have a lot of pairs I can take out here. So 1 pair of 2s, 2 pairs of 2s, 3 pairs of 2s, and I have this 1, 2 that's left over. So when I write this, I'll have 2 times 2 times 2, 1, 2 for each pair I took out, and then the square root of 2 for the last 2 that I did not have a pair for. And then 2 times 2 times 2 is going to give me 8. So this will be equal to 8 root 2. And again, I can do the same thing with a negative square root, or square root of a negative 128. The only difference here again is that I'm also going to be pulling out a square root of negative 1, which is an I. So this will essentially give me the same exact thing, except the only difference is I'll have an 8I root 2 instead.